Hi guys, how are you? I think you all guys are doing well. Uh, this is the part 2 video of the number systems concept in aptitude, quantitative aptitude to be precise. This is all about the concept of number system. In this part 2, we are going to discuss about the important formulas. Let me, okay, in the part 2, we are going to discuss about the important formulas, tests of divisibility, test to be a number prime. So this is the second video of this channel. I hope you guys satisfied with the part one of this number system. Without doing any late, let's dive into the video of part two. Okay, yeah. So important formulas. Some of the important formulas are a plus b whole square is equal to a square plus b square plus 2ab. This is the formula which we have all in 10th class we have studied, right? Not in 10th class, from 8th class onwards also we have using this formula. This formula is important while solving numericals, like the huge number of data at that point of time. This formula is so much important. Okay, yeah. uh, Next, a minus b whole square is equal to a square plus b square minus 2ab. This is also most important while solving the numerical problems, okay, which have large amount of data at that point of time. It's very useful for us. So I will discuss numericals after completing these conceptual videos of number system. At that point of time I will explain you guys examples of this where we are going to use these formulas. I will tell while solving the numericals. If I tell now, it will be a very long video. So I just wanted you guys to be memorize these formulas. Okay. Yeah. Next formula is a plus b whole square plus a minus b whole square equal to 2 of a square plus b square. This is nothing but addition of these two, right? The third one is nothing but the addition of these two. If you perform addition of these two will be cancelled, and the formula will be 2a square plus 2b square. When we take the common 2, then it will be 2 of a square plus b square. Okay, I hope you understand. Next, a plus b whole square minus a minus b whole square. A plus b whole square minus a minus b whole square is equal to 4ab. So if you are going to see this, this is also same as this third one is addition of both, and the fourth one is subtraction of both. We are going to minus, then is here minus this both are will be cancelled, and this minus becomes plus. Okay, this minus becomes plus, and this both will be added, and the resultant will be 4ab. Okay, next. A plus b whole cube equal to a cube plus b cube plus 3ab of a plus b. Okay, this is also formula which is a plus b whole cube, and a minus b whole cube is equal to a cube minus b cube minus 3ab of a minus b. Okay, yeah. A square minus b square is equal to a plus b into a minus b. Next, a plus b plus c whole square is equal to a square plus b square plus c square plus 2 of a b plus bc plus ca. How to memorize this formula? See, uh, to memorize this formula, it is a plus b plus c whole square, right? First, you individually square the each and every term, which is a, b, c, and add it. Okay, and then you multiply two two items, a, b, c, and c, a. Okay, and add them. Okay, and the power is two, right? So multiply them. So like this here. In this way, you memorize this formula, okay, which is some big formula, right? Up to till you can able to memorize because it is in the eighth class, right? In your eighth class, all these formulas will be there, right? But this also will be there, but most of the people usually forgot this formula. So I've told this how to memorize this formula. Okay, next, let me erase it. Okay, a cube plus b cube equal to a plus b into a square plus b square minus ab. So you have to memorize these formulas. Okay, a cube minus b cube is equal to a minus b into a square plus b square plus ab. So this is also a formula which is it is very familiar to you guys, but you may be forgotten because it's a long gap, right? Eighth class means it's a very long gap. So yeah, a cube plus b cube plus c cube minus 3ab is equal to a plus b plus c into a square plus b square plus c square minus ab minus bc minus ca. Next, if a plus b plus c is equal to 0, then a cube plus b cube plus c cube equal to 3abc. It is a proof in eighth class. I, I hope whether you remember or not, it's a proof in eighth class. It's a 7 mark question, I think so. Yeah. So I'm not gonna discuss problems related to these formulas right now. So I want you guys to memorize this all these formulas. Okay. I need you guys to memorize this all these formulas. After the after part 2 there will be a part 3 video which is related to some concepts of number systems only. After that I'm gonna solve numericals. So at that point of time, while solving the sums, I will discuss why these formulas are important for us. Right now, if I discuss the conceptual part will be left. So I'm not discussing these formulas right now. The main thing I have done, I have put this slide because in this gap, I want you guys to memorize these formulas. Okay, let's go to the next topic. Tests of divisibility. Tests of divisibility is nothing but the divisibility rules. Divisibility rules means uh, if a number, for example, if a number given like this 492, 492, and uh, and we have given some other numbers 2, 3, uh, sorry, 2, 3, 4, 5, and so on. See, among these numbers, if a question like this, among these numbers, what are the numbers that can able to divide this number 492? What is your answer? So we have to divide this, right, with 2 and 3 and 4 and 5, right? It will take a long time, right? Uh, without dividing and we have some shortcuts to tell whether the number is divisible by uh, given numbers or not. So those shortcuts will be discussed in the divisibility rules. For each and every number there is some particular divisibility rule. For example, for 2 there will be some divisibility rule, 3 there will be some divisibility rule, and 5 there will be some divisibility rule. All those will be discussed right now. Okay. Yeah, divisibility by 2. Okay. A number is divisible by 2. A number is divisible by 2 if its unit digit means the rightmost digit, right? Unit digit means ones place digit. It has 2, 0, 2, 4, 6, 8, which means even number, right? If the rightmost digit has 2, 4, 6, 8, then the number will be divisible by 2. Let's see. Yeah, the given number is 58694. The last number is 4, right? So you can simply tell that this number is divisible by 2 without dividing this whole number by 2 and uh, waiting till getting the remainder equal to 0 for that time. It will be a long process, right? So without doing the division, we can say by saying its unit digit for ones place digit or unit digit, and you can say that because it's 4, right? So which is an even number, so we can say that the number is divisible by 2. Okay. While there is another number which is 86945, uh, in which there is the unit place digit is 5, which is not a even number, and in that case it is not divisible by 2. We can simply say like that. So it's a shortcut, right? So you don't need to divide this whole number by 2. So by just saying that the unit place digit, you can able to decide whether it is divisible by 2 or not. Okay. Yeah. Next. See, it is unit digit, right? Unit digit means only we are going to check one digit, right? The last digit we are going to check, right? So there will be a relation between two divisibility rules of 2, 4, 8, and 16. Okay. In divisibility rule of 2, we are going to check only last digit, which is a single digit, right? This, okay, yeah. If the last digit is 0, 2, 4, 6, 8, or it is divisible by 2, for example, 4. Here in this case, 4, right? If 4 is divisible by 2, right? 2 ones, 2 twos, isn't it? Yeah. And in this case, 5, right? 5 is not completely divisible by 2 because 5 twos are 2 twos, 4, right? The remainder will be 1, okay? It is not completely divisible by 2. It means we are not getting the whole number, right? It it is we will get to 2.5, right? It means we shouldn't take zero point 0.5, right? Where we shouldn't say that if we have points, the quotient is in the form of point value, then we can shouldn't say that it is divisible by 2. Okay. So what my point is, we are going to check only unit place digit, only single digit. Whether it is divisible by 2, then the whole number is divisible by 2. So similarly, the 2, 4, 8, and 16 numbers are divisibility rules are similar because we can write 2 in the form of 2 power 1, right? We can write 4 in the form of 2 power 2, right? Right? We can write 8 in the form of t cube, right? We can write 16 in the form of q power 4. So in the case of q, in the case of q, we are going to check the unit place digit only. We are going to check the unit place digit only, which means single digit. Okay. Now you tell me, uh, in the case of 4, how many digits from the right we are going to take? It is 2. Why? Because we are going to represent 4 in the form of 2 power 2. In the power we have 2, right? So we have to take rightmost two digits. For example, in this case, we have 94, right? If the same number, whether we have to say it is divisible by 4 or not, we should take the tens place 9 and the ones place 4, and we should divide this number by 4. 4 ones, 4 twos, and 1 4 twos, and the remainder will be 2, right? It means this number is not divisible by 4. Like this way we can say, able to say, okay. The what I want to convey you is, for 2 we are going to take only ones digit, for 4 we are going to take tens, and ones combinedly. Okay, we are not going to check whether both the digits separately divisible by 4 or not. Like this we are not going to check. We are going to take that as a whole number, that complete number, and we are going to divide it. Okay, if it is divisible and we got the remainder equal to 0, then the particular number will be divisible by 4. So similarly in the case of 8, the last three digits, the last three digits divisible by 8, not 2, 8. Then the number will be divisible by 8. Why only the last three digits? Because we are going to represent 8 in the form of 2 cube. Okay. Similar in the case of 16, the last four digits divisible by 16, not 2. Okay, divisible by 16. Then the number is completely divisible by 16. Okay, I hope you guys understood this. Okay, for in the case of q, the last one digit is divisible by 2, then the number is divisible by 2. For the case of 4, the last two digits, two-digit number divisible by 4, divisible by 4. Here in the case 2, divisible by 2. Here in the case 4, the last two digits divisible by 4, the number will be divisible by 4. Here in the case 8, if last three digits are divisible by 8, then the number divisible by 8. Here in the case 16, if the last four digits are divisible by 16, then the number will be divisible by 16. Okay, I hope you got this. Okay, let us discuss that in the uh, I will show you slides. Okay, I hope you got this topic. Let me erase this. Yeah, yeah, completed. See, divisible by 4. A number is divisible by 4 if the number is formed by last two digits. Not in, we shouldn't take individual numbers, tens separately, ones separately, like that. We shouldn't take. We should take tens, ones digit combinedly. Number formed by its last two digits is divisible by 4. Then the number is divisible by 4. Here the number should be divisible by 4 only. What we are going to take last two digits, that number is divisible by 4 only, not 2. Remember that my point. Okay. Here in the case 6879376 is divisible by 4. How we are going to say? We are going to take last two digits. Why? Because 4 can be represented in the form of 2 power 2 as I discussed previously. So we are going to take last two digits which are 76. 76 is divisible by 4. How? 4 ones, 4 ones, and remainder will be 3. 3 here 6. It means 4 nines. Okay. So 4 19s is 76, which means 76 is divisible by 4. So then the given number 6879376 is also divisible by 4. Rather than dividing this whole number by 4, we are going to take only last two digits and making it divisible by dividing by the 4. If it is getting the remainder, we can be able to say that the whole number is divisible by 4. Okay, next. Similarly, here in the case 496138 is not divisible by 4. How that we have taken last two digits, okay, because it's 4, 2 power 2 is equal to 4, right? So we are going to take 38. 4 4 eights are 32, right? Remainder will be 4 nines are 36, right? 4 nines are 36. Remainder will be 2, which means we are getting remainder as 2, not 0, right? So we can say it as this number is not divisible by 4. Next, divisible by 8. A number is divisible by 8 if the numbers formed by last three digits. See, why three digits? Because 8 can be represented in the form of cube, right? As I already discussed, but I'm gonna give you notes also. See, cube, okay? Then the number will be set to be divisible by 8, okay? Yeah, see guys, example. See, we are going to take the last three digits, 352. So if the last three digits divided by 8, then the number, this number is how many digits? 1, 2, 3, 4, 5, 8 digits, right? Then this number will be divisible by 8. So 8 ones, 8 fours are 32, right? 8 fours are 32, and the 3 will be remaining, and here 2, 3 2 means 32, again 8 fours are 32, which means 44 times 8, 44 times equal to 352, which means 352 is divisible by 8 and getting the remainder as 0. We can say that 1678932 number, which is 8 digit number, is divisible by 8. Okay, yeah, this number we are going to take 5764 484, which 484 is the last three digits of the number, which is let's see, 8 6 48. Okay, 8 6 are 48, have 0, and we are taking the 4, right? It's not divisible, right? Remainder is 4. Yeah, we have to do. For suppose if we're gonna put also, it's not divisible. Yeah, next, divisible by 16. So divisible by 16 means 16 can be written as 2 power 4, right? 2 power 16 can be written as 2 power 4, which means 4 digits. Last 4 digits we have to take. Okay, last 4 digits. Okay, is divisible by 16. Then the number will be divisible by 16. So I forgot to tell you, in the case of 8, if last 3 digits is 0, the number is divisible by 8. Remember this point. In the case of 4, if last 2 digits are 0, then the number is divisible by 4. Okay. In the case of 2, if last digit is 0, then number is divisible by 2. In the case of 16, last 4 digits are 0. If last 4 digits are 0, then the number is divisible by 16. Okay. This is the one point you have to remember. And we are going to take last 4 digits, right? So in this case, 3776 we are going to take from the number 4637776. It is divisible by 16. Okay, yeah, once you check it. Okay, yeah, so let's discuss about the divisibility rule by 3. Okay, a number is divisible by 3. A number is divisible by 3 only when the sum of the digits is divisible by 3. For example, 7 to 9, which is a three digit number. We are going to add all these numbers. 7 plus 2 will be 9. 9 plus 2, 9 plus 9 will be 18. 18 is divisible by 3 or not? Yeah, which means this particular number 729 is also divisible by 3. That's the meaning of this statement. Okay, let's see an example. See, in the number 695432 1. Okay, 2 plus, we, are, we will add these numbers. Okay, 2 plus 1, 3. 3 plus 4, 7. 7 plus 5, 12. 12 plus 6, 12 plus 9, 21. 21 plus 21 plus 6, which is 27. If you are really confused, you also can able to add this. You got final result as 27, right? If you add this, you will get 9. If 9 is divisible by 3, yeah, which means this whole number is divisible by 3. Okay, you either after adding, if you get two digit number, if if you can have, if you know tables very well, then you can say whether 27 is divisible by or not, because 27 is a very small number, mean big small number, right? So we can able to say it's divisible by 3. For example, something 89, 89, and uh, the sum is result is 92, like these numbers if you got, means you just add those two numbers, add to those these two numbers and you will get 11, right? You can say that but that particular number is not divisible by 3. So what I'm telling is, after adding this the digits in this number, we are getting again the two digit number or the three digit number. Then you add that number also. In this case, you get 27, right? We add 2 plus 7 again. Okay, we will get 9. If 9 is divisible by 3, then the number which is given to us, this is also divisible by 3. Okay, this is my point. This is some of the shortcut. That's it. Okay, yeah. In the number you got 35. Okay, after adding all this, you got 35. 35 is not divisible by 3, so the number is not divisible by 3. Okay, yeah. Similarly, uh, for 3 and 9, both the same. But for 3, if the sum of the digits of a number is divisible by 3, then the number is, we can say that the number will be divisible by 3. For the 9, if the sum of the numbers is divisible, the sum of the digits in the number is divisible by 9, then the number, we can say that divisible by 9. So this is the rule, divisible by 9. When the sum of the digits of a number is divisible by 9, then the number which is given to us, we can say that divisible by 9. In this case, 2, 4, 6, 5, 9, 1. The sum of digits is 27. Let's check. 9 plus 1, 10, 10 plus 5, 15, 15 plus 6, 21, 21 plus 4, 25, 25 plus 2, 27. 27 is divisible by 9 or not? 3 is 9 3 is 25, 27, right? So which is divisible and remainder is 0, right? So we can say that the given number 2, 4, 6, 5, 9, 1 also divisible by 9. If you are previously I told a trick for 2, right? The sum of the result of these digits is 2 digits, right? If you are going to add these two, okay, 2 plus 7 again, okay, then you will get 9. 9 is divisible by 9, right? So in this way also you can able to tell. I'm telling that only if you want to follow my logic, you can follow. Otherwise, if you are confusing, then you can just uh, add the digits which are given. Add the digits in the number which are given to us, which has been given to us one time. If you are not able, confusing, then you can add till you get the single digit number. Okay, yeah. The next number is 734,512. The sum of digits is 29. 29 means which is not divisible by 9. In my shortcut, after you getting 29, after adding all these numbers, you get 29, right? If you add 2 plus 9, you will get 11, right? Okay, 11 is not divisible by 9, right? So in this way also you can able to do. Yeah, next 10. Oh, it's very easy. I can't. It's very easy, right? But I put it because you should have a very idea, right? You should have very clarity in your mind, right? So I put this divisibility by 10. Okay, a number is divisible by 10 only when unit digits is 0. Okay, unit digit means ones place, right? Ones place. Hope I have been better. then last class. Yeah, next. See here the unit digit is 0. So simply we can say that it's that a given number is divisible by 10. The unit digit is 5. So simply we can say that it's not divisible by 10. Okay. For the 5 rule. Divisible by a number is divisible by 5 only when its unit digit is 0 or 5. Okay. Yeah. Each of the number is, yeah, both the numbers is divisible by 5, right? Because in the first number given the unit digit is 5, right? And then in the second number the unit digit is 0, which means the both the numbers are divisible by 5. Okay. Yeah. For 5 and 25, previously discussed about 2 fours, 2 4 8 16, right? Similarly for 5 and 25, 125 also say has the same method. We can write 5 as 5 power 1, right? Which means we have to check first digit. First digit means unit place digit. That is unit place digit is divisible by 5 or not. Or if the unit digit has 0, then we simply can able to say that the given number is divisible by 5. Similarly, 25 can be written as 5 square, right? So it means we have to take last two digits and we have to check whether the last two digits are divisible by 25 or not. If last two digits are divisible by 25, then we can able to say that given number is divisible by 25. Okay. Or the last two digits are 0, then we can simply say that the given number is divisible by 25. Okay. Similarly 125, for 125 we can write it as 5 cube. uh 5 cube, 5 cube means it is going to represent in the power 3, right? So we have to take last three digits of a given number. Okay. If last three digits of a given number is divisible by 125, then the given number is divisible by 125 whole number. Okay. If the last three digits are 0, then you can simply say that last simply say that the given number is divisible by 125 without doing any doing- yeah, it is, see, either 0 0 point number is divisible by 120, divisible by 25 if the number is formed by its last two digits is either 0 0 because uh, we can represent 5 square, right? 25, for 25 we can represent it as 5 square, right? Similarly, also discussed about 2, 4, 6, 8, 2, 4, 8, 16, right? For 2, if last is 0, we can say it's divisible by 2. For 4, if last two digits are 0, we can say it is divisible by 4. For 8, if last three digits are 0, we can say it is divisible by 8. For 16, it's for a given number last four digits are 0, so we can say that given number is divisible by 16. Similarly, in the case of 25, if last two digits are 0, we can say that given number is divisible by 25. This is because we are going to represent 25 in the form of 5 square, right? Which is in power we are going to have 2, right? So we can say the given number is divisible by 25, uh, or else the last digits are divisible by 25. We can say that given number is divisible by 25. Okay, next. Yeah, see, we are going to take last two digits, which is 75, 25 ones, 25 threes, right? Which means 75 is divisible by 25 and remainder is 0. Okay, remainder is 0, which means the given number 63875 is divisible by 25. Okay, yeah. Here the last two digits are 45. We are going to take 45. 45 is not divisible by 25, right? So, or we can say that the given number is not divisible by 25. Yeah. 11. Divisibility rule of 11. A number is divisible by 11. A number is divisible by 11 if the difference between the sum of its digits at odd place and the sum of the digits it's at a even place is either 0 or a number divisible by 11, then the number is divisible by 11. Okay, so it means, let us take a example 121. Okay, so uh zeroth place 1 1, so you can take anyways. So it's even, uh odd place even place means you have to take it as 0. Okay, 0 ones place, or you can take anything, take it as 1, or take it as 2, take it as 3, or take it as 0, take it as 1, take it as 2, as your wish. Okay, so for example, if you're going to take it as like this, positions as like this is 1, uh, the 2 is 2, and the last one is 3. So we are going to add odds place and evens place. Here the odds place is 3 and 1. In the 3 we have 1, in the 1 we have 1, which means 1 plus 1 is equal to 2. In the even place, actually we are having only one even place, which is 2. In two's place we have 2, right? So if you are going to subtract both of them, the resultant is 0, right? So we can say that given number is divisible by 11, or 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 the number is or the number is divisible by 11. For example, either it can be 0 or it's a multiple of 11, like 11, 22, and 33, like this. Okay, then we can able to say that the given particular number is divisible by 11. We can see example. Yeah, consider the number. Okay, so this is 1, this is 2, this is uh, as you can take as you wish. You can take it as 0 and you can start. You can take it as 1 and you can start. Anything will be same. Okay, 4, 5, 6. You have to number it. Okay, 8. So let us add odd places. In the first place we have 7, right? 7 plus, in the third place we have 4, right? 4 plus, in the fifth place we have 3, right? 3 plus, in the seventh place we have 9. Okay, we are going to add 7 plus 4 is equal to 11, 11 plus 3 is equal to 14, 14 plus 9 is equal to how much? 23. Yeah. Next, we are going to add the positions of going to add the values at the even places. Okay. In the second place we have 1, right? 1 place. The fourth place we have 5. Sorry. In the fourth place we have 5, right? The sixth place we have 4. In the eighth place we have 2. Okay. 6, 10, 12. Okay. 5 plus 1 is equal to 6. 6 plus 6 plus 4 is equal to 10. 10 plus 12. Okay. 10 plus 2 is equal to 12. We got the answer as 12. So which of the following is largest number? This is right. So we have to subtract the 12 from the 23. We're going to subtract 12 from 23. We will get the answer as 11, right? 11. Is 11 divisible by 11 or not? Yeah. And the remainder will be 0, right? Well, perform 11 by 11. So the given whole number is divisible by 11. Okay. If the for suppose if you got this as 23 and you got 23 minus 23 equal to 0, then also this number is divisible by 11. Okay, or else if you got the difference is 22 or 33, like this multiple of 11, then also the number is divisible by 11. Okay, I hope you got this point. Okay, let's see sum of digits at even places or odd places, that is this. Okay, this is the part, sum of digits at even place. See, this we have done. Okay, so we have separated. Yeah, actually, you got this value as largest, right? So you have separated the this number from this. Okay, if you got this number as largest and this as smallest, then you have to separate uh, this number from this number. Okay, it means you have to see like that. So this is the thing that they performed here. Okay, so we got 11. So 11 is divisible by 11. So we can say that number is divisible by 11. Okay. Uh, for this number, you guys perform. Okay. In the slide also will be there. So we are going to take the positions, right. 1, 2, 8, 6, 7. See, odd place 2, 8, 6, 7. Which are left? Those will be even, right? Obviously. Yeah. 2, 3, 4, 5. 23 is the sum of odd numbers, and 14 will be the sum of even numbers. Then the difference between them will be 9, just not divisible by 11. Okay, yeah. Let's discuss about 7 or 13. If, for example, if you given a number, a big number, okay, divide the number into groups from the right. From the right means from the ones place, like this. Unit digit from this. Okay, into three digits. Here will be three digit, here will be three, yeah, three digits, and here will be three digits. Okay, I'm gonna explain. Okay, from the right, okay, find the difference between the sum of numbers in odd and even places. It means one, you also previously for the 11 you have mentioned, right? Here you have to mention for the group. Okay, you will be divided into groups like uh, three bits, sorry, three digits, right? Like this. So you have to number uh, the values for the group like this. Where is this? Yeah, one, two, three, four, five, like that. We have to again there be added, right? In the case of 11, we have to add odd places. Ones place, two, threes place, and fifth place, and fourth and second you have to add, and you have to separate odd addition of odd places minus even, or even minus odd, based on the largest which we have getting in odd or even. You have to see that. Okay, if the resultant is 0, similarly if the result is 0, then the given number is divisible by 7 or 13. If the given resultant is 7, divisible by 7, which means resultant is the multiples of 7, then the given number is divisible by 7. If the resultant is divisible by 13, or the resultant is multiple of 13, then the given number will be divisible by 13. Okay, so this is the point. Let's see an example. Yeah, so from the right means this is the ones place, right? Given number, we have given number, so we have to three digits. We have to divide into three digits. This will be 1 if you are going to mark this 1, 2, 3. Okay, odd will be 1 and one's position and third's position, right? So we have, you will be added this. 792 plus 4 minus 537, right? So that will be done here. Okay. Okay. 730 plus 4 minus 537, it will be 259, which is divisible by 7, right? Because 7 ones, 7 threes are 20. Yeah, yeah, there will be problem. Yeah, I'll look into it. Okay, just a second. Yeah, sorry for the interruption. Yeah, 7 threes are 21, right? The remainder will be 4 and 9. 7 7 are how much? 49, which means 37 times, right? 37 times the 7 will be 259, which is divisible by 7, right? It is not divisible by 13 because you just check 259 divided by 13. If you do do this, it is not divisible by 13. Okay, yeah. Similarly, there is some other example. We have divided into three parts. It will be 1, it will be 2. Here not have any other, we have only odd place as 1. There is no other odd place. We have only even place as 2. There is no other even place. Here the even place value is highest than the odd place. So we have to separate the even place value with odd place. See, yeah, the resultant will be 91, which is divisible by both 7 and 13, because if you are going to do with 7, 7 ones are 7, remainder will be 2, 2 1, 7 threes are 21, 73 times. Okay, yeah, is it okay? 13 times, sorry. I also mistaken here, right? Yeah, 13 times. I have just mentioned the value. Yeah, and it also divisible by 13. Check it because the video is running out. Yeah, note. Here comes the very best part of this video. If a number is divisible by p as well as q, where p and q are co-primes, then the given number is divisible by pq. Pq means it's the product. Okay, it is p into q. Okay, so just telling this statements is not the my way of teaching. I will explain this statement with an example. We're going to take 6. Okay, what are the factors of 6? 1, 2, 3, 4. Sorry, 4 not 6, right? Take any two co-prime numbers. So I'm gonna take 2 and 3, which are co-primes, right? Co-primes, because those HCF will be 1, which is I already discussed in the first class. The common factor for 2 and 3 will be only 1. Highest common factor, okay, will be 1. So is 6 divisible by 2? Yeah. Is 6 divisible by 3? Yeah. 2 threes are 6, 3 twos are 6, right? So if a given number is divisible by 2, if you have given a long big number, if it is divisible by 2 and not or and divisible by 3, then without doing the divisible by 6, we can able to say that that particular big number is also divisible by 6. Okay, for example, if you're going to take 36, you know already 36 is divisible by 6, right? Is 36 divisible by 2? Yeah. Why? Because the last digit is 6, which is an even number, or last two digit is 6, which is divisible by 2. Okay. Is 36 divisible by 3? Yeah. Why? Because if you add both the digits, 3 plus 6 equal to 9. 9 is divisible by 3 in 3 times. Okay. So without performing the addition between, without performing the division of 36 by 6, we can able to say that 36 is divisible by 6 because 2 because 36 is divisible by 2 and 3, which are co-prime numbers, which are the factors of 6, right? Yeah. For example, I'm gonna take another number 216. Is 216 divisible by 2? Yeah, because there is 6. As last digit, we have 6, right? Is 216 divisible by 3? You have to check it, right? 2 plus 1 equal to 3, 3 plus 1 is equal to 9. Yeah, it is divisible by 2 and it is also divisible by 3. Which means we can say that 216 also divisible by 6. This is the point about this statement. Uh, you have to note it down. Okay, yeah. See, there is also another point. Let me erase this. If P and Q are not co-primes in the sense their HCF is not equal to 1. Their HCF might maybe equal to greater than 1. I think so. Okay. Yeah, I think so. Not. It's a HCF is greater than 1. Then those are not co-primes, right? Then the given number need not to be divisible by P and Q. We can't able to say that. Okay. Even when it is divisible by both P and Q individually, we can't able to say that it is divisible by the product of P and Q when the P and Q are not co-primes. But when P and Q are co-primes, then we can able to say that the given number is divisible by PQ, which is the product of both the numbers. Okay, so let us see some examples. 36, as I have discussed, 36 is divisible by both 4 and 6, but it is not divisible by 24, which is the product of 4 and 6, right? Because 4 and 6 are not co-primes. The HCF of 4 and 6 is 2, because what is meant by HCF means one can able to divide the 4 and 6, right? But 2 also can able to divide the 4 and 6, isn't it? Yeah. So here HCF becomes 2, right? So even though 36 is divisible by 4 and 6 individually, if we multiply the 4 and 6, we get 24. That 36 is not divisible by 24. Why? Because 4 and 6 are not co-primes. So this is the meaning of that line. Second line. Actually, I explained the first line to you guys, right? Now the next. So this is the divisibility rule. 2 on 3. Okay. If you multiply 2 on 3, you'll get 6 automatically. Yeah. Next. Divisibility rule of 12. 3 and 4. 3 and 4 are having the common factor as 1, highest common factor as 1. If you multiply 3 and 4, you automatically get 12. If a number is divisible by 3 and 4, then automatically the number is divisible by 12. Why 3 and 4 only? Why not 1 and why not other 6 and 2? Why not 6 and 2? Why 3 and 4 only? Because why 3 and 4 are co-primes who they are having HCFS 1, where 6 and 2 are not co-primes, they are having HCF as 2. So we can't able to say that whether this product we can't able to say like that uh, whether the given number is divisible by 6 and 2 individually, then we can't able to say that the given number is divisible by 12 or not. We can't confidently say that it can be, in some cases it can be happen, in some cases it can't able to happen. But when we are going to consider the co-primes like 3 and 4, we can able to say that if the given number is individually divisible by 3 and 4, we can able to say that it is definitely divisible by 12. Okay, so we should have to consider only co-primes. Okay, co-prime factors. Co-prime factors. Okay, see. Co-prime factors we should consider. Next, for the 15. For the 15, we have 3 into 5, which are co-primes, actually having HCF of 1. Yeah, 18. A number is divisible by 18 if it is divisible by 219. 219 are having factors as HCF as 1. 6 and 3, we have, if we multiply 6 and 3 also, we are getting 18. But 6 and 3 are not co-primes because their HCF is 3. Because 3 ones, 3 twos, right? So HCF is 3. I will discuss HCF topic next coming lectures because it's the next chapter I will discuss there. A number is divisible by 14 if divisible by 217 because 217 are co-primes. Divisibility rule of 24. A given number is divisible by 24 if it is divisible by both 3 and 8. 24 having factors as 1, 2, 3, yeah, 4, isn't it? 6, next 8, and 12. I may forget anything. Yeah, oh, 24. So in this, we have to take two numbers which should be co-primes, and those multiplication should be equal to 24. If we are going to take 6 and 4, 1 and 2, those are co-primes, but those multiplication is not equal to 24. So you shouldn't take it. If you are going to take, let me change my link. If you are going to take 2 and 3, those are co-primes, but those multiplication is not equal to 24. You shouldn't take it. Next, if you are going to take 3 and 4, 3 and 4 are co-primes, but those multiplication is not equal to 24. It is 12. Okay, multiplication is not equal to 24. It is 12. We are going to take 4 and 6. Those multiplication is 24. 4 6 are 24. Okay, but those are not co-primes. Those are not co-primes because highest factor is 2. Okay, we are going to take 6 and 8. 6 8s are 48. Even multiplication is not equal to 24 and both are not co-primes. Okay, if you are going to take 8 and 12, similarly, it's not equal, right? Similar 12 and 2. Okay, if you are going to take 8 and 3 only in the case of 24, if you are going to take 8 and 3 only, we can able to say whether 24 is divisible by, if the given number is divisible by 24 or not, because 8 and 3 are co-primes, and if we multiply both the numbers we will get 24. Okay, yeah. Next, 40. Let me erase this. Okay, yeah. Similarly, for the 40, we are going to take 5 and 8. 5 8s are 40, and 5 and 8 are co-primes. So not only the condition is the condition here is in the previous slide co-primes, but when you are going to uh, multiply those two numbers, to those resultant should be equal to that number. Okay, so 5 and 8 if we multiply 5 and 8, that is equal to 40. Okay, so 5 and 8 are co-primes. So we can say that only the such pair will be only one pair. 5 and 8 only. Okay. I explained you about 24, right? Similarly, you check it once for 80, 40 and 80. A given number is divisible by 80 when it is 5 and 16 only. Okay. when it is divisible by individually divisible by 5 and 16, individually divisible by 5 and 16. Okay, next. Yeah, it's been 1 hour exactly. Let me discuss. Yeah, okay. Just for a number to be prime. Okay, let p be a number, given number, n be the smallest counting number, n square greater. It's n square. It's n square. Okay, it's n square. Greater. I will change it. Okay, p. Now test whether p is divisible by any of the number less than or equal to n. Less than or equal to n. Prime numbers we should take. Prime numbers we should take. If the number p is divisible by, if the number is divisible by, number p is divisible by those numbers, those prime numbers which are less than n, then the number is not a prime number. If the number p is not divisible by such numbers, those numbers which are less than n, which satisfies the condition n square greater than or equal to p, okay, then that number we can able to say it as a prime number. Let's discuss example. Okay, these are the following. Um, Let me erase. These are the following examples. Some they have given. So I will do for the one thing, one only. After you do for others. Okay. See, they have given five numbers. Okay, 131. So it will be taken as p. So we have to take a number, we have to spare a number which should be greater than 137. What is the perfect square number that is nearer to 137? One is 121 and one is 144, right? So what I have told, the number should be greater than 137. It means you shouldn't take 121. Okay, you should take 144. 144 can be written as 12 square, right? 12 square. 12 square is greater than or equal to p. P means here what? 137, isn't it? Yeah. What is n here? N will be 12. N will be 12, right? So we have to take prime numbers less than 12. Prime numbers less than 12 will be 2, 3, 5, and 7, 11. Only after we will get 13, right? This is greater than 12, right? So we shouldn't take that. So we have to check whether the 137 is divisible by these numbers 2, 3, 5, 7, 11. So let us check it. Is 137 is divisible by, is 137 is divisible by 2? No, because the last unit digit is 7, which is not even, and it is not also divisible by 2. Is not divisible by 2. Okay. Is it divisible by 3? We should add 1 plus 3 plus 1 plus 3 is equal to 4, 4 plus 3, 4 plus 11, 4 plus 7 is equal to 11, which is not divisible by 3, means it is not also divisible by 3. Okay, so 5, in case of 5 the last digit should be 5 or 0. Here the last digit is 7, so we can't able to it is not divisible by 5 also. 137 is 137 divided by 7, so we should divide the number into three groups, right? But here actually we are having only three numbers, right? For the divisibility rule of 7 is we have to divide the numbers into, given the number into three group. Okay, but here actually given number is three numbers, right? Three digit number, right? So we have to divide it. Okay, 7 okay, we have 66, right? 67, 67, 7 9 is 63. 63 means we are getting remainder as 4, which is not divisible by 7 also. Okay, So let us see with the 11. 1 plus 7 will be 9. We have to take odd position and even position, right? 7 will be 7th position, 7 then okay. I'm getting I have some problem of talking, so don't mind. If you have any problem, just tell me, okay? 137, right? So you have to take even and odd places, right? One, if you take 1, 2, 3, okay, then 7 plus 1 will be 8, right? 8 minus 3 will be 5. 5 is not divisible by 5 is not divisible by 11, right? Which means it is not also divisible by 11. The 137 is not divisible by less than or equal to 12 prime numbers. Okay, it means the number is a prime number. If the number 137 is divisible by any of these numbers, then it is not a prime number. Okay, let's see. So we know that 12 square is equal to 137. Okay, next 12 prime numbers less than 12 are 2, 3, 5, 7, 11. Okay, next none of them divides 137 because we have seen this, right? So he directly I have given that. Okay, 137 is a prime number. Okay, yeah. So similarly 173. If you're going to take 14 square, how much? Yeah, going to take 14 square, you will get some number, right? How much? You will get 196, right? You will get 196. So if you take 13 square, if you take 13 square, you get 169. So the number 173 is less than is greater than 169. So we shouldn't prefer 13. We should prefer 14. Okay. So the prime numbers less than 14 are 2, 3, 5, 7, 11, 13. Okay. None of them divides 137. None of these numbers divides the 137, 173. So 173 is a prime number. Okay. Similarly, the next number, you check it. Okay. You check this third one. This is the homework for you guys. Okay, this is also homework for you guys. Okay, this on also homework for you. I have given you three homework sums because I can able to do the sums. But if you try this, you will have on product practice on the divisibility rules. Okay. Uh, so I have given you homework. That's the first reason, and the second reason is the time is running out. It's already been 1 hour 10 minutes. So I have given you those as your homeworks. In the coming lectures, we have some concepts like factorial, modulus, greatest integral part, or like the small concepts we have. Those will be discussed. I think that will be a short video, around 30 or 20 minutes. After that, I'm gonna discuss problems. Okay, I'm not gonna discuss all the problems. See, while performing doing any quantitative aptitude or any aptitude, you should always do a smart work. Okay. The first thing is always to do a what smart work. We have to learn the whole concept. In learning of the concept, we shouldn't do any shortcuts. While solving the problems, we should eliminate the some of the sums. Most of the people do these mistakes. They usually practice the questions which are known to them only. They don't touch other questions which are difficult, which will be felt difficult to those persons. Okay, so what I'm going to do is I'm gonna discuss only the toughest problems which are students are going to feel about. Um, so what I'm trying to tell you and what I'm suggesting you is you learn the concept depthly. You didn't miss even single concept while learning. But while solving the problem, you do not solve all the problems. You solve only some set of problems. You should keep the models. You should keep yourself while practicing models. Model this is model one, this is model two, this is model three, model four, model five, model six. Like this, you have to arrange in your mind. Okay, so this is all about the video. Uh, thank you, thank you guys.